Hey everyone, in this video we're going to talk about using LaunchDarkly to control application changes in a Kubernetes environment. My name is Peter McCarran. I'm a Senior Technical Marketing Engineer here at LaunchDarkly, and so let's dive into a little bit about what we're going to cover in this presentation. So first and foremost, if you're watching this video, you're likely familiar with Kubernetes or you've at least heard of it. You may be wondering why organizations have made the move over to microservices. So we'll touch a little bit about what some of the benefits of a microservice environment are. Like any good presentation, we're going to have an analogy that we'll work off of. So we'll build that up, make sure we have a real world reference for everything we're going to talk about. We're going to apply that analogy back to our application architecture. We'll do a quick demo as far as like how this all works together, and then we'll recap everything at the end. So before we dive into the analogy portion of things, we need to actually set this up. So why are organizations actually using something like Kubernetes? Why are they making the shift over to microservices? Well, to me, there's really three major benefits that organizations have when they move to a microservice environment. First and foremost, microservice environments like Kubernetes, they're very scalable. I can support large enterprise workloads. I can use things like governance or RBAC policies to be able to control access to my pods and be able to have consistent security policies across different pods and different clusters. They're also observable. Typically with a Kubernetes environment, we've broken apart a monolithic application. So we're running a series of microservices and we can measure the performance of each one of those individual services. I also have the ability to map out the visual topology of how my services are interacting together. And I can also export metrics to see how they're performing and get a better understanding of where I can make improvements within that environment. The last piece is that Kubernetes and microservices in general offer us the idea of speed. You've heard of continuous integration, continuous delivery. When I have a microservice, I can frequently deploy new versions of that application and I can scale it up or scale it down without having to rebuild either the entire application or the entire infrastructure that's underlying this. Now, if you have seen a LaunchDarkly talk before, these should sound pretty familiar to you in terms of value propositions. The way we look at things at LaunchDarkly is our goal is to help you be able to achieve release management at scale, which means that we want you to be able to consistently roll out new workloads, have automated rollout policies, as well as being able to implement governance policies for the folks of who has the capability to make releases and who has access to those changes when they become available. But beyond that, we also want to help you optimize your products. So one of the things we want to do is make sure that we can use experimentation to be able to ingest data about the changes that we made and be able to measure the business value enhancements that these new changes have done. So this is a huge part of the software delivery process. When I make a change, can I know what those impacts are? And finally, from an application modernization standpoint, LaunchDarkly is designed to help you in your transition to cloud and microservice environments. We can do things like progressive rollouts. We can do different testing before we make it live for everybody. We're trying to help you in that transition process that allows you to see how the new infrastructure will affect your new applications. So the values are similar, but ultimately the practices are going to be a little bit different. So when we think about this, we have two different sides. We have how we think the application changes are going to go, and then the reality of how Kubernetes actually handles those application changes. So on the left side here, what we have is we want to look at this really being more like a pit stop. I have my application, I want to make changes. So in this case, maybe I need to swap out the tires, change the oil, make some enhancements to it, and then I send it along its way and everything is right. The challenge there is that that's not really how Kubernetes actually handles application changes. In a Kubernetes environment, it's going to look more like this. So what we're seeing here, and I'm a huge Simpsons nerd, so that's why I had to include that GIF in here, but ultimately this is the way Kubernetes handles a change. It destroys the entire environment, or in this case the pods, and it relaunches an identical pod with just the small minimal changes that we made. This seems a little bit wasteful if all we're trying to do is change the color of the bedsheet that we're going to have on there. So this is where we kind of set up our analogy, right? So really the way we want applications in Kubernetes to operate is like an F1 race car. So if you think about the team that handles things in an F1 race car environment, we have our car. So the car in this case would be our application or our container. The track in this case would represent our Kubernetes environment. So it's a fixed infrastructure that we have to follow the rules of the road on. If you're in a NASCAR road, you always got to turn left. You can't turn right. The pit crew and the mechanics are really our development team. They're the ones who are trying to make changes that'll optimize our performance. And then the drivers and the tower are really more like our platform or our operations team. They're kind of keeping a lay of the land, making sure that everything's operating correctly. If something seems to be going wrong, they can inform the development team or the pit crew or the mechanics that a change needs to be made to address those. So if we're drifting to the right, maybe we need to make a change to our tires. Or if we're noticing some drag, maybe there's something going on with the engine that we need to tweak in order to fix it. And so if you think about what F1 teams want, they want high performance. So they want to win races. Everybody likes when we win races. You get to celebrate, pop the champagne bottles. All our fans are happy. We get more sponsors. And ultimately, the entire team feels more accomplished. The other piece is we're trying to minimize our failures. Not only are crashes bad for winning races, but they also can be expensive. If I'm constantly having to change out or replace my car, that can get very costly. And so my ownership team or my sponsors may not be happy with the amount of money that I'm spending on new cars. The other piece is that we want to be able to gather analytic data that helps us improve the performance. So if we're doing well, we want to be able to get better and be able to measure what the differences are and how we can improve those changes. So on the converse side, what we don't want is we don't want struggling or lagging performance. If we're consistently coming in last place, we're probably not going to get some sponsors. We're probably not going to make our fans very happy, and we're probably going to lose good talent on our driver or on our mechanical team. We also want to minimize crashes. Again, crashes are bad for everybody. It costs a lot of money. It's very dangerous for our drivers. It can be dangerous for even some of the fans. We really don't want to have a lot of crashes be a part of our regular race routine. And we also don't want uncertain futures, both from we don't want something that is causing a poor performance that we can't detect or we don't know what's happening. And conversely, we want to know what's working and what made things go right. It's not helpful if we win a race and we don't really know why or what change we made that might have impacted that race. So if we tie this back to our application and our development team, when we think about Kubernetes and applications, we can cover the same kind of benefits in those three core points that we're trying to achieve. We want to be able to get a better performance, so we want to be able to adjust and make changes on the fly without having to tear everything down and redeploy it all. We don't want to swap the engine out on the car every single time that we want to try something different. If we want to try one set of tires versus another set of tires, you don't have to replace the entire vehicle. Same thing with our application. If we want to test one interface versus another interface, we shouldn't have to tear down the underlying infrastructure in order to test that change. We also want to minimize our failures. So if something goes wrong, we want to be able to quickly recover from that without creating a lot of impact to our end users. So we're trying to avoid outages, we're trying to avoid crashes. It's bad for our customers and it's bad for our internal users. And lastly, we want to know if we have data that shows us why things are going the way that they're going. If something is going better or we want to be able to improve something, we want to be able to run things like experiments to gather information about what the change does to our application and be able to implement those changes if we see that there's something that could get better or remove something if it's causing a problem. So we want to make sure we have good analytical data for all these things. So the reason that gets tricky in a Kubernetes environment, and the reason we're talking about this is, and I apologize, this is a little bit of an eye chart, but if you look at the configuration for an application in a Kubernetes environment, it kind of looks something like this. On the left here, we have a full YAML file. It's about 64 lines of code, nothing major. On the right side, though, shows that really the application piece of this is really only the one line. Because what we're doing is we're telling Kubernetes to pull this image for the application, and that's what it should deploy in this pod. So you might be saying, well, then what are the other 63 lines of code that I have in here? A lot of it is infrastructure configurations. It's things like memory allocation, it's things like port rules, it's service definitions, maybe I have annotations because I'm using a service mesh with this. There's a number of different things that I would put into this, but that's really more about the environment. That's more about the overall structure of the car, and the one image line is our engine. So, again, we talk about this idea that you shouldn't have to replace the engine every single time that you are that you want to make a small change. Now, sometimes you do have to replace the car. I'm not trying to say that using something like feature flags is going to completely eliminate your ability to avoid crashes like this. If you've used Kubernetes, you've probably seen this status code before. If you're getting a crash loop back off, that means you probably have to change something about your configuration. Either the image is not working properly, it wasn't packaged correctly, or there's something else going on that we need to do a little bit of a deeper dive and probably replace our whole car. But if we just wanted to, again, test out a different tire configuration or test out a different oil, we shouldn't have to replace everything. And so when you're using feature flags or LaunchDarkly with Kubernetes, there's really four main benefits that you can derive from this. So first and foremost, this allows us to iterate on live applications. Applications that are running in Kubernetes can still leverage feature flags because when I set them up and the flags are in the code, I can run tests against live traffic and it stays consistent across replicas. So remember, one of the benefits we said about Kubernetes is that I can have multiple replicas of a single application in order to handle traffic demand. But when I use something like LaunchDarkly and feature flags, I can make changes to all those replicas without having to re-roll out everything. The other piece is I can use flags for traffic management. One of the things we talk a lot about is this idea that feature flags are really full stack solutions. They often go hand in hand with front end changes, but I can actually use them in like a Kubernetes environment to be able to change the directionality of where something should reach out to. So in the demo example that we're going to show here in a bit, we're using a feature flag to be able to determine the API path of the database that we're going to hit. And I don't have to redeploy the pods. I can actually test them out in a separate environment and then connect them to my front end application when I feel that they're ready. The other piece is that we can deploy with consistency. So as pods scale up or they scale down, I'm going to be able to meet demand without having to make sure that I'm using the same image every single time. The data is going to be consistent because ultimately it's going to retrieve the flag value from LaunchDarkly. So even if I haven't changed the code itself, but there's a feature flag in place, it's going to launch the one that's consistent with the flag value that I'm currently presenting. And finally, I can collect experimentation data. So as we mentioned, if something's going well or not going well, we want to know why. We want to be able to run experiments against our applications to have a better understanding of what's happening in our environments, just like we do when we move over to a microservice environment. So now we can measure both things. We can see the impacts of infrastructure changes that we make, as well as the impacts of application changes. So with that, we're going to flip over to a quick demo. Hey everyone, in this demo, I'm going to quickly show you how you can use LaunchDarkly with a Kubernetes application. Before we do that, let's level set a little bit about what we're looking at on the screen here. So on the left side, I'm using a tool called Console. This is just showing my services that are running. I have a couple of different APIs, I have some front-end elements, and I have a couple of different Postgres databases. And that is all resulting in what you see on the right side, which is just rendering my application. So before we talk about the LaunchDarkly piece, let's talk a little bit about how Kubernetes actually handles application changes. So the thing to remember is that Kubernetes is an infrastructure platform. So the way that it was designed is to be able to spin up new infrastructure very quickly and dynamically, as well as being able to scale with demand. When you're making application changes in a Kubernetes environment, you really don't have a ton of control to the actual application code that gets loaded. So let's take a look at what I mean by that. So in my terminal here, I have a front-end YAML file, and most of the code that's in here is really just defining the infrastructure that I want it to run when I do my apply. And the only component that is actually showing me the image, the actual application that we're running within this pod, is defined in this one line of code. So if I was going to make a change to my application, like if we saw on our last screen we had light mode, maybe we want to enable dark mode, what I'd have to do is go make the change to the application, push it to whatever version control system that I'm using. That'll likely trigger some sort of Docker build, and then I have to come back here and I have to redeploy it to Kubernetes. So we're going to do that real quick just to see what happens, but you're going to notice it's not the most seamless change. So if we go up here, and we're going to edit our file, and we'll go ahead and redeploy it. So if we swap back over to our screen here, you're going to notice something happen on the left. On the left, we see this instance change, and then all of a sudden we get a warning. The reason that we're getting this warning is because what's happening is that new pods are deploying, and as those new pods come online, it's destroying the old ones. So as I go ahead and I start refreshing my screen here, I'm not going to see anything really change. I ran this as what's called a replica set. So there's actually 3 pods that are hosting my front end here. And before I can see anything change, Kubernetes has to spin up the new pods with the new code. So if I keep refreshing it here, there's a couple different things. Either I'm not going to see something, or I'm going to see a blank screen like this, or an error message because I'm hitting a pod that no longer exists. So we're going to keep spinning this around. Once again, we're not going to get anything that's loaded. Keep trying. Now we see our dark mode coming up. But if I keep refreshing, you're going to notice that it's going to switch kind of back and forth. The reason that it's doing this is the ingress piece that I'm using is actually hitting each of these different pods. It's balancing those requests between those different pods because it doesn't want it all going to the same thing. So now that we have this online, you see this is loading, everything is good. But there's a better way for us to do this. We know that. We can use feature flags. So if I go into my LaunchDarkly account here, and we open up my dashboard, you're going to notice that I've already created a dark mode flag. That's what we're showing on display here. So if I change this and I flip this off, we're going to switch back to our light mode. Now, the cool thing here is that because I'm doing this on the application side, because I'm changing the application code, if I refresh, I'm always going to see the same thing because it changes for all of my pods. So those 3 replicas that we had, they're all getting the same message that they should all be showing light mode right now. If I switch it back to dark mode, it's going to change. And again, we're going to consistently see the same application loading. So we're not going to run into that circumstance where things are changing back and forth, or if we hit an error message. So that's the very base value, right? Like that's a great thing that we can do within our front end application. But there's other things that we can do. There's some cool stuff that we can do as far as like handling traffic patterns using flag values. So if I go back over to my code screen here, I have this component in my React application that is basically this client. So I'm using a GraphQL client with a tool called Apollo. What Apollo is doing is that it's essentially reaching out to my Postgres databases and returning some query values that I have. And what I've told this to do is I've told Apollo to reach out to the path that is the same value as a flag that we've called API address. So I've actually set, this is the reason that I have this set up for 2 different Postgres databases, because I can dynamically control which renders depending on which one I want to hit based on the API address value. So let's look at that flag and see what that looks like. So the API address flag is a targeting flag that's going to do a couple different things. What this is going to show is that I have my DC universe users, I have my Marvel universe users. And depending on who I log in as, I'm going to see a value that gets returned back that makes sense for that person. So if I log into my application here, let's say I'm going to log in as Tony, you're going to see the heroes of the Marvel universe. Same thing where if I wanted to switch over, maybe now I'm Clark, I'm going to see the heroes of the DC universe. And I can switch back and forth between these. And one of the cool things about Kubernetes is it's easy for me to run multiple pods that contain different Postgres databases, and then I can just point to the one that I want to use using flags. So once again, just to show, I can log in as Thor. Okay, that's a little weird that didn't work. Oh, yeah, sorry. I got these values from Tony, so I got to log him in as his name, Point Break. There we go. Now it's going to work. So we're controlling the address of which one we want to hit, but there's even more that we can do. What we can say is maybe within that database, I have a different table that I want to query, or I have a different query field that I want to be able to use. What I can do is I can actually change that. Again, if we go over to our code, within our search function, we have this flag value of table, and I'm returning a certain field if it returns the value back of heroes. And we're using this hero query. So I could set this up where I could use different query fields to query different tables and return those values back to my application and then make those changes without actually having to change the database at all. So if we flip back over to our flags and we load up our table, you'll see that basically my variations are that I'm either using that heroes table, so then I should use the heroes query, or I have the villains table. And if I switch on the villains table now, you're going to see that we now have the villains of the Marvel universe that are rendering here. Nice thing, we've added an enhancement where we can show the nemesis that they're going against, and it's going to return these interesting values. Because if I'm logging in as my heroes, I probably care who the villains are. And once again, we can switch over to our DC universe, and we're going to see the same thing, where I'm now pulling the villains of the DC universe. So hand in hand, I'm using a couple different flags to be able to query different tables within different databases, and it's spread across 2 different databases. And again, I don't have to make any of these changes by applying new pods or spinning them up online. So we did this mostly in the React app itself, but I easily could have done this also in like that Nginx pod, where I could have pointed to different values depending on where I wanted those directions to go. I could have done this on the server side, so I could have changed it so that I return different pathways based on different values. There's a lot of flexibility that you can do when you sprinkle LaunchDarkly all throughout your Kubernetes deployment. I hope you found this helpful. Thanks for watching. I hope you all enjoyed that pre-recorded demo about how we can use LaunchDarkly to control changes in our applications that are running in Kubernetes. But what I wanted to do is just step back a little bit and kind of talk about the art of the possible of what we could have done beyond what we just did in that demo itself. So this diagram that you're looking at right here is kind of like a visual representation of what that demo consisted of. So we had a React front end that was using Nginx as a reverse proxy that was talking to a couple of Node.js Express servers, which were serving a couple different Postgres databases. And so all the flag changes that we made in that demo were all using the React client-side SDK. So we were actually making all the changes still on the front end, even though we were using it to control some of our back-end behaviors. Now, if I wanted to move this further down the stack or to different elements, I could have used something like the Lua SDK, where I could have said, I'm going to make different changes in our proxy paths that are going to be based on a specific flag value so that the Nginx server is ultimately what's going to serve up the different values as opposed to everything being rendered on the client side. I also could have used the JavaScript SDK and made some of those changes in my node servers. So I could have made different kind of assessment paths on the node side to say if the flag value is this, we should serve this path, or if it's this, we should serve a different path. That's great if we're doing something like a database migration. Maybe we're going to, instead of use a second Postgres, we're going to move something over to like MongoDB, for instance, but we want to do a progressive rollout and we wanted to do a controlled rollout before we flipped it all over to the new database. I could have done that using a feature flag on the node side, and the front end wouldn't have had to change at all. So really what you start to see is that I have the capability of actually integrating feature flags into any type of microservice that I may be running in my Kubernetes environment. And something like LaunchDarkly is great for that because we support so many different languages. So the way I kind of frame it is whatever code you're going to be writing in and packaging for a pod, you have the opportunity to be able to control changes using a feature flag. So to quickly recap what we covered in this video, we talked about how feature management and microservices really strive for the same value, but ultimately they don't always operate in the same way. If you remember way back when, we showed our car visual where we want to make a pit stop, be able to swap things out and go on our way. But the reality is that application changes in Kubernetes are really that pod refresh, burning the bed type of life cycle. And that's not always the best practice when we're trying to make smaller changes. The other piece is that we want to have DevOps teams have harmony, just like an F1 team. So we want our developers, our operators, our platform teams to all work in harmony together to be able to win the races. The last piece is we're trying to strive for three things. We want to maximize our performance, we want to minimize our failures, prevent those crashes, and we want to improve our metrics using real data.